So we've got three functions graphed right over here, and then we have three equations right over here that could describe these functions. And once again, we need to figure out which ones will match with which other ones. And I encourage you to pause this video right now and think about it. So let's go equation by equation, and at least let's try to write them in a form, or at least look at parts of them that will be make it a little easier for us to figure out which ones match up. So let's look at this first one right over here. So this first one, instead of just taking the trouble of multiplying all of this out, I really care about the highest degree term and maybe the lowest degree term. So let me just try to figure those out. So I could rewrite that one as y is equal to, the highest degree term is essentially going to be, we're going to take the product of these four expressions, negative 1 over 11 times x minus 5 times this times this. So if we take the highest degree part of each of them, that's going to give us our highest degree term. So it's going to be negative 1/11th times x squared times x squared. So that's going to be x to the fifth, right? X squared times x squared is x to the fourth times x is x to the fifth. Negative 1/11th x to the fifth. And then it's going to be plus a bunch of stuff. And then our lowest degree term is going to be, let's see, it's going to be negative 1/11th times negative 5, which is positive 5/11th. Actually, let me just write it this way. Plus negative 1/11th times negative 5 times positive 10 times 2x. Whatever, I guess we could work this out. This is what, negative 100 over, or positive 100 over 11. But let's just leave it like this. That's going to be our lowest degree term. I just took the lowest degree from each of these expressions that we're going to be multiplying together. And so this is another way of viewing it. And what's useful about this one is we can immediately think about the end behavior here. So what do I mean by end behavior? Well, we've covered this already. Let's look at the coefficient on the highest degree term. And let's also think about whether the highest degree term is odd or even. Since we're dealing with an odd degree polynomial, this is x to the fifth, and this coefficient on the highest degree term is negative, this is going to have end behavior like, so end behavior like negative x to the third. And what would negative x to the third look like? Well, when x is really negative, it's going to be really positive, because x to the third is going to be really negative, but then you're multiplying it times a negative. And then when x is really positive, x to the third is going to be even more positive, but we have a negative out front. So it's going to be really negative. It's going to be really negative. So this function is going to look something like this, and it's going to do probably some crazy things in between. So which of these look like that? Let's see. F starts high, then it goes high up again, so it's not that one. G starts low and ends up high. This starts high, ends up low. So the only one that's left, this is actually kind of plays tricks with the eye. The only one that's left is the dotted purple one, which is, actually, do they even have a label on this? Well, we'll call that one H. That one is H. And let me highlight it because I know it's hard to see. So this one right over here, notice, end behavior. It starts for very negative values. It has a very high value for our function. Then it does all sorts of crazy things in between. It does all sorts of crazy things in between. And you can actually see that it clearly has 1, 2, 3, 4, 5 roots. But that's not what we're really concerned with for this sake. And then after it does all that crazy stuff, as x gets really positive, the value of the function becomes really negative. So its end behavior is like, negative x to the third. So we can feel confident that this right over here, that this function right over here is h of x. Now, in other videos, I've looked at the intercepts, but what is the y-intercept for this one? Well, when x equals 0, this whole thing is equal to 0, because the lowest degree term isn't a constant, it has an x in it. So when x is 0, this whole thing is 0, and that's consistent. Actually, all three of these have a y-intercept of 0, and you see that's because all three of them have a lowest degree term that involves an x. So we can really just concern ourselves with the highest degree terms. So now let's think about the next function, and I'm going to give myself some real estate here. I don't want to scroll down just because I want to be able to look at the graph. So let's look at, oh, my phone's ringing. Actually, this isn't more important. Let me work on this video. So this next one right over here, let's just think about what it might look like. It would look like y is equal to, its highest degree term is 1/10 times x squared times x squared. So positive 1/10 times x squared, which is x to the fourth, and then plus a bunch of other stuff. So what's its end behavior going to be? Well, it has an even exponent on its highest degree, or it's a even degree polynomial, and the coefficient on that highest degree term is positive. So it's going to have end behavior. It's going to have end behavior like positive x squared. So when x is really negative, the value of the function is going to be really positive. And then when x is really positive, the value of the function is going to be really positive. And it might do some kind of crazy things in between, because this obviously isn't x squared. It has all sorts of crazy terms there. So which of these functions looks like that? Well, let's see. Our f has that it's when x gets really negative, it gets really positive. And when x gets really positive, it gets really positive. And it's the only one that has that type of behavior. So we can say fairly confidently that f of x is this function, or this function is f of x. And then once again, deductive reasoning, we can think that this last one is g of x, that this last one right over here is g of x. But let's verify it. So if we were to try to think about its highest degree term, it would be y is equal to 1/11 times x squared times x squared. So 1/11 x to the fifth, and then plus all sorts of other business. So here you have an odd degree, it's a fifth degree, and you have a positive coefficient on that fifth degree term. So it's going to have end behavior. So it's going to have end behavior like positive x to the third. So when x is really negative, the value of the function is going to be really negative. And when x is positive, the value of the function is going to be really positive. And it's going to do all sorts of crazy things in between. So which one looks like that? Well, g looks like that. As x gets negative, the value of our function gets really negative. As x gets really positive, the value of our function becomes really positive, and it does all sorts of craziness in between. So we can feel good that that one is g of x.